Alright, welcome to College Algebra, Unit 2, Day 3. We are working on, we are working on page 11 of the note packet. We're working on just figuring out the end behavior, so not actually figuring out what a function is doing. So we're looking at the meaning of a polynomial function, so something like with multiple terms like x squared plus 3x plus 2, so as an example. Poly means many, so many terms. We're going to look at graphs of higher degree than 2. So we're going to understand the end behavior, meaning the left-hand side, so LHS, and the right-hand side, because everything likes to be abbreviated now. We're going to sketch the graph of higher degree and zeros. You've done the zeros before, so now we're just kind of incorporating them into what we are doing on the endpoints. Okay. So this looks very long and complicated and kind of gross, but this is what a polynomial looks like, where the A stuff are numbers. Then you have x to some exponent, so x to 5th or x to the 4th or something like this. With a sub n not equaling 0. So we're going to have something with variables involved. It might be any degree, it could be 2, 3, 4, 5, 6, 7, 8, whatever we want. Now this is what you generally see, especially when you look at the quadratic formula. So this is a quadratic of degree 2. Okay, polynomials are one continuous, which means there are no breaks. So you can't pick your pencil up and like some of our piecewise functions, they are separated. This time there are no breaks, so something even, like up and down and up, whatever it is. It doesn't matter how much curves it has to it, but it's just going to be up and down versus we're not doing this. So polynomial on the left, not a polynomial on the right, not in pieces. Okay, you've seen graphs of x squared. And actually if we graphed x to the 4th, or x to the 6th, which is the inside one, so x to the 6th is this inside, x to the 4th, and then x squared. You can see as the degree gets higher and higher, it goes up faster and faster. So instead of going wider, it goes up faster, closer to the y-axis. Now, these are all even degrees, like we talked about in the notes. Even, even, even. So even degrees. And it's going to ask you about the behavior of the graph with an even degree. When it means behavior, they're asking about what is going on the left-hand side. So what's going on like up here, and then what's going on over here on the right-hand side. So left side, right side, left side, right side. So we're just talking, it's not like you don't have to give a specific number. You're just saying, is it going up or down? And again, we are looking at a, the value in front of the function. So in these cases, in this and this, it's all 1. If a is positive, and you have even, so these are for even functions only, so the degree, the biggest exponent is even. The right-hand side and left-hand side are both up. I don't care how far up they go, but they're both going up in the graph. Now, if a is negative, even if if the degree is even, the right-hand side and left-hand side are both down. So something like negative x squared. Okay, the a value is here, and this is an even degree. It would be upside down, flipped parabola from what we did in the first unit. Left-hand side down, right-hand side going down. So even is really nice. You look at the biggest degree. If it's an even number, then the graph will be going the same way on both sides. Sorry. Now if it's an odd degree, so if we have 3, a 5, a 7, or a 9, again the a value in front of it is a positive. they are all going to act the same way. So a to the third is on the inside here. A to the fifth is in the middle. A to the seventh goes out wider. So it's kind of the opposite of when the degrees get bigger on an even, they get narrow. When the e's get bigger on degrees get bigger on an odd, they go wider. All right, so the behavior. If A is positive, so like these, a 1, a positive 2, a positive 3, doesn't matter the number if it's positive. The right hand side, so right hand goes up, and the left hand side goes down. And something like negative x to the third, it reverses itself. Ooh, sorry. Left hand, right hand. Okay, if A is negative, the right hand side is down, so they reverse. They just switch. Left hand side goes up. Okay, so they just flip flop. An odd degree even, or sorry, odd degree positive A, odd degree negative A. All right, so on the other side, we're gonna do a little bit more. So flip over to page 12 and begin the next video.